Okay, everybody. I want to talk about a little bit about applications and how we can use them. So here's a question that relates to my previous video on permutations and combinations. So determine the number of ways that 6 people can be arranged in line at a ticket counter. Determine the number of ways that 6 people can be arranged in line at a ticket counter. So, since no 2 people can be the same, we are only arranging 6 different distinguishable items in various orders. So in that case, all we're looking at is 6 factorial. And we know 6 times 5 times 4 times 3 times 2 times 1, and we get 720. Okay. Now let's look at this particular question. It's in the topic of permutations, but the way that the problem strategy is designed is different. So here we have a word, microscopic. We're going to look at the word microscopic. Okay. So in this word, we want to find out the unique number of arrangements of these letters. So the word microscopic has 11 letters. All right. So we have 11 letters. Okay. However, the letter I appears twice. So there are I appears twice. So let me just write this 2. Here. So there are 2 I's. The letter O appears twice. So there are 2 O's. And the letter C appears 3 times. Now, the way the strategy is, we want to design the problem like this. Start first with the total number of letters possible, and that is 11. So it's 11 factorial divided by, so we had 2 I's, so that's 2 factorial, 2 O's, 2 factorial, and 3 C's, so 3 factorial, equals, this will have to be done on a calculator, so you can try it, 1,663, 1,663,200. So the number of unique arrangements of these letters is, and we have it, 11 factorial divided by 2 factorial times 2 factorial times 3 factorial. Now, once you understand and you practice these problems and you learn the techniques, you will get it. You won't have any problems with this style of doing math. So I want to look at problem that relates to both permutations and combinations. So in this case, I have a committee of 12 people. So a committee Whoops. We have a committee of 12 people. In this committee, how many ways can we choose a chairperson, a vice chair, a secretary, and a treasurer? All right, so we have a chairperson, okay, a vice chair, a secretary, and a treasurer. Assuming that one person cannot hold more than one position. So we have a committee of 12 people. We have a chair, a vice chair, a secretary, and a treasurer. And we want to know in how many ways can we choose a chairperson, vice chair, secretary, and a treasurer, assuming that one person cannot hold more than one position. Well, we can do this by using what we studied, introduced in the last video. So we have the total number. So we have 12 people on the committee, and there are 4 positions. So we end up with 12 factorial. I'll write it right over here. Divided by 12 minus 4 factorial. Which is 12 factorial divided by 8 factorial. Now remember what I did last time. I'm just going to multiply 12 times 11 times 10 I'll put it down here. So that's 12 times 11 times 10 times 9 times 8 factorial divided by 8 factorial. They cancel. So I'm just multiplying 12 times 11 times 10 times 9, and I end up with 11,880 ways of filling these positions. Okay, so that's with the permutation. Remember, we had a committee of 12 people, and we needed to fill those 4 positions: chair, vice chair, secretary, and treasurer, assuming that one person cannot hold more than one position. Now, in the next part of this question, in how many ways can we choose a subcommittee of 4 people? Okay, so it looks almost the same, but we're going to use our combination formula because we just want to form a group of 4 people. So the order we choose people in is irrelevant. That means we have 12 C, our combination formula. So we'll end up with 12 factorial over 12 minus 4 factorial times 4 factorial. So we'll get 12 factorial times 8 factorial. There's a factorial there. Times 4 factorial. And we end up with 12 times 11 times 10 times 9. 1 simplified over 4 factorial. And our final answer will be 11,880 divided by 24 equals 495. So there are 490 ways of choosing a subcommittee of 4 people from among the 12. Okay? Now, let's see here. So when we're doing problems, if you can remember these two setups and when to use them, and try to take each problem and imagine and match up with the examples that we had, this one and this one. With a little bit of practice, you'll be able to do many problems like this. And this one. These last two are very, very related. All right, so I'm going to post some problems and get in touch and let me know how you're doing.